Good morning. Good afternoon. Today we came to our plumbing class day, day 13. Today we will be taking classes on uh, water balancing, as well as STP, okay, sewage treatment plant. We just studying about uh, some brief ideas about STPs, okay, sewage treatment plant. And so, and if you have time, we will be taking some, topics on this pump valves, etc. Okay. So anyways, we can just move on to sewage. Now, before sewage treatment plant, we can just focus on water balancing. So, water balancing is nothing but like if you have an underground tank or an overhead tank. Okay, you know how we are trying to balance it, or how much water supply has to be given to the domestic purpose, how much water supply we have to do the flushing purpose, how much we have to give for irrigation purpose, okay, surplus water, what we have to do with, okay, all those water balancing thing we need to know it, okay. So water balancing is nothing but how much amount that can be given to a particular usage. Okay, that's what it means for you can call it as a water balancing thing. So for water balancing, we have a water balancing diagram. So water balancing diagram is nothing but like it depends upon different projects. It depends upon different quantities of water that is available to us. Okay, so if you get a question or if you get a problem to solve, uh, how to balance the water or how to provide water for individual things that we need to know. Okay, for individual usage that we have to know. Okay, so it is. I will share a chart, like I will share a flow chart like that. So if we get a if you have an desired amount of quantity of water available, so how we will be distributing that water? Okay, that's what it meant. Okay, water balancing means how to distribute the water for a particular purposes. Okay, so if you have a 10,000 liter water, how we will be distributing it? We need for flushing, we need for drinking, we need for domestic purposes, we need for gardening. How we can just divide it? How we can just distribute it properly? Okay, that is called as water balancing. This just we need to have an idea. That's all. Okay, nothing much to study or about all these things, but we need to have an idea how we are distributing this or how we are for different purposes. Okay, so initially I will share a flow chart regarding water balancing. So, just look here. So this is about water balancing diagram. Water balancing diagram. So you can see here, this is the supply source. This is the supply source, and this is the demand and secondary supply source. Okay, this is the demand. So you can see here a municipality water is there. So or corporation water. Okay, a corporation water is there, and you'll be having a water which is being recycled from STP. So you know what is this STP? STP means sewage treatment plant only. Waste water, used water from our buildings is being collected in the sewage treatment plant. It will be, sewage treatment plant will be treating the water and we'll be getting some purified water at the end. Okay, that water can be utilized for different purposes. So here, this is the supply source. We have a municipal water tank and we have a recycled water through the STP. Okay, so it's a huge project. Just imagine this is a huge project, and 39 cubic meter. Okay, cubic meter. Water per day. Okay, you have this much amount of water is being stored in this municipality underground tank or corporation water tank. Okay, so you have 39 cubic meter of water or meter cube of water per day is being stored in the municipality tank. Now we have 40 cubic meter of water per day from this STP. Okay, from this STP we will be getting 40 cubic meter per day from this STP. So now we are trying to distribute this water for our demand. Okay, this both are the supply source. One is the municipality and another one is recycled through STP. So in different application it can be different. Some days there might be having rainwater tank. Okay, some days they will be having borewell or normal well. So it will be different. Okay, the supply source will be different. Okay, the supply source of water will be different for different projects. So mainly we are trying to deal with this because this is a big project. You take this as an example of an apartment or a flat or something like that. Okay. So from municipality, you will be getting 39 meter cube of water from STP, recycled from STP. Treated water from STP, you will be getting 40 cubic meter per day. So you can see this arrow, and this 39 cubic meter per day is being sent to the domestic use. The water from the municipality is being, supplied or pumped to a domestic use for the complex. So just imagine this is some complex. So this is being used. 39 cubic meter of water per day is being used for this domestic purposes. Okay, and you can see this 40 cubic per meter per day is being distributed equally. Distributed equally in the sense from 40 cubic meter, 37 cubic meter per day is given for flushing purpose. Okay, 37. Okay, 37. So the water that is coming out from the STP is not so pure. We cannot drink, or normally we won't use for washing or bathing or for anything like that. Okay, so from this 40, almost 37 cubic meter per day is used for flushing. Okay, and 1 cubic meter per day is used for irrigation. Okay, irrigation purpose for this complex. Okay, for this complex. Okay, and you have 37 plus 1, 38. Again, 2 more is there. So 2 cubic meter per day is a surplus water. Okay, so in this case, we have for irrigation purpose we need only 1 cubic meter or 1000 liter per day. Okay, for irrigation use. So already we have 40 cubic meter is being produced. So you can use this much is being demanded for flushing purpose for this complex. It demands almost 37. Okay, imagine it demands almost 37. So plus 1, 38. So 2 is surplus. 2 cubic meter is surplus. So that surplus water can be discharged to municipal sewer. Okay, to municipal sewer. So this is the way that we are distributing it. Okay. Now, from the domestic use, okay, domestic use in the sense we can use it for washing the clothes, bathing, lots of other purposes like washing our hands, washing our faces, etc. Like that. We can use it. Okay. So we can use the water for health faucets, etc. like that. Okay. So this 39 cubic meter per day of water is being given to the overhead tank of domestic overhead tank for domestic purposes or for domestic usages, in which almost 10% is being, you can just imagine that 10% is being evaporated. So if you are using 90, if you are using for example 100 liters of water, okay, if you are using 100 liters of water, then 100 liters of water won't be discharged, because some water will be evaporated and some will be it will be it should be lost. Okay, losses can happen. Okay, so we are using 39 cubic meter per day. So just 90%, if you multiply with 90% of 39, you will be having only 34. Okay, the available water which is being discharged from the toilets or from kitchens and other areas, the discharged water won't be 39. You might be utilizing 39, but the water from the toilets and other areas after your utilization won't be 39 itself. There will be some losses, correct? Like evaporation loss or something like that. Some losses will be there. So just take a 90% of it. So you'll be getting almost 34 cubic meter per day, or cubic meter or meter cube of water is being drained out, okay, after the usage. So you'll be getting 34 cubic meter per day. So here it is for the flushing only. So flushing in the sense it will be directly going into the water closet. From the water closet it will be directly flushed out. So how much water is being supplied for flushing, that much water will be coming out. Okay, in the normal sense. There won't be any losses will be there. Okay, because it is not exposed to any other areas. Okay? So directly the water will be coming, then from there itself directly it will be flushing and it will be coming out. So there won't be any action in the water. There won't be any reduction in the water. So from this 37 is the coming out. 37 cubic meter is been coming out from the flushing. Then 34, almost 90% is coming out from the domestic use. Now irrigation, that will be used for irrigation. So on irrigation it will be absorbing, right? The plants will be absorbing, the soil will be absorbing, so you won't get anything else. So it's for irrigation. So you will use 34 cubic meter per day and 37 cubic meter per day from flushing and 34 from domestic. Okay, almost you will be getting 30 plus 30, 60, 66, 71 cubic meter per day will be getting from total. Total will be getting 71 cubic meter per day from this domestic water tank as well as from flushing tank. Okay. So imagine that your STP capacity is 45 cubic meter per day. Okay, this STP can be different. Okay, just imagine that 45 meter cube is the capacity. Okay, of the STP. So you cannot give more than 45 because the capacity is 45. Correct. So you cannot give the 71 to the STP. So 45, so 71 minus 45 is 26. Correct. So 26 is the surplus water. So the surplus water can be given into the surplus water to be discharged to the municipal sewer. So whatever the surplus water is there, that surplus water can be discharged. That surplus water can be discharged into the municipal sewer. Municipal sewer. So from there it goes to the STP. So this is the treated water. This is not the treated water. This is the wastewater only. This wastewater will be settled in the STP, and in STP, sewage treatment processes will be carried out. And from there, what will be there? We will be having 45 cubic meter per day will be there. It will be circulated. From there, some losses will occur in the STP itself. Some losses like backwash will be there, sludge holding tank and drain will be there. So some water will be drained like that. Some backwash will be there. So some water will be lost like that. Okay. So almost an approximate 5 cubic meter per day will be lost as a loss. Okay. So the STP capacity is 45. Will be the water that will be settled, or the water that will be treated water at the end of the sewage treatment plant or the sewage treatment tank will be almost 40 cubic meter per day. Okay, that will be given to the STP. Okay, that water will be 40 cubic meter per day. So 45 will be carried out here. 5 will be lost. Okay, 5 cubic meter per will be lost from this 45. So this is the way that we are trying to balancing it. Okay, water balancing. If there is some surplus water will be there, that surplus water has to be discharged into the municipal sewers. So this is just a water balancing thing. Okay. So then we are going to find the NDC. We will be able to know, okay, how much we need domestic, how much water that we need for domestic purpose, how much water we need for flushing purpose. We will be able to know it. Irrigation also will be able. Last day we were dealing with irrigation and how much water that we needed. So thumb rule itself we will be able to know it. Correct. And not only that, we have already solved a problem regarding the irrigation. Okay. So how much water that you need, okay, but also you have found out, okay. Now, as a thumb rule, we already found out that the in order to find out the you know uh, amount, okay, just multiply the area with 0.02. Okay, so you'll be getting the water storage. Okay, water storage for that. Now, I think I have already shown you about the NPC only. So let's see how to uh, just I will show you how much should be the flushing requirement and how much should be the domestic requirement. So this is a screenshot that I have already taken from the NBC only. This is the type of building. Okay. Okay, this is the type of building. In NBC, you can go to page number 612. Okay, in there only you'll be having about the plumbing. Plumbing. Okay, National Building Code of India about plumbing. You can go to this page number 623. Okay, 623 of NBC 2016. You'll be getting. If you want this chart, you go to 623. Okay, and in there different types of buildings will be shown here. Different types of buildings will be shown. And anyways, I will be sending you the NBC. Okay, I will be sending you the NBC tables, and that form will be sent to you, so you can just go through it. Okay, so these are the different types of building. By the end of this week, I will send you. Okay, so these are the different types of building. You can see here different types of building. Factories including canteen, where bathrooms are required to be provided. Factories including canteen where no bathrooms are required. So hospitals are given. Different hospital ranges are given here. Number of beds not exceeding 100, number of beds exceeding 100, like that. Nurses' homes and medical quarters, hostels, hotel, 3-star, 4-star, like that. Restaurants, stadiums, clubhouse, cinema theaters, schools, okay, shopping, traffic, okay, railway stations, etc. All these things are given. Different types of buildings are given. Okay, and you can see here domestic per day. Okay, domestic usage per day it gives in liters. Okay, and flushing you can see gives in liters, and total consumption. So they have already divided it into two. So for example, in your house there are for example 10 people. For example, 10 people. You just imagine 10 people. Just assume 10 people are there. Okay. Okay. So in that case, you have to go to this. Okay, and for example, if you are dealing with this NHS homes or medical quarters, okay, or hostels, okay, in a hostel, just imagine there is, just imagine there is a 10 people. So how much liters of water can be they demand, or how much water are they being used in a day? Okay, so you can just go here, go to the hostel, and you can see here is this 90 per head. You can see here 90 per head, right? You can see here domestic it is 90 per head. So one person uses 90 liters of water per day. That's what it meant. Okay, they use 90 liters of water per day for domestic only. Domestic in the sense they might be using for bathing and washing and all those things will comes in domestic. And flushing, you will be using for water closet only for flushing out. Okay, so 45 liters per day per head. Okay, so 90 liter for domestic as well as 45 liter for flushing. So if there are 10 people, just multiply with 10, you will be getting 900 liters. Okay, so and 45 you will be getting 450. So almost in this case it will be half. Almost in this case it will be half. Okay, half in the sense domestic. If the domestic water tank, if you are taking it for 2 days, for example, 1 day itself, you are taking for 100, or 1000 liter is the tank capacity. 1000 liter is the tank capacity. Imagine for domestic purpose. So if it is 45, it will be 500 liters per day. If you are using for 1 day storage, if you are using for 1 day storage, okay. So according to this, so when you see this, this will differ. Number of people differing, or number of or liters per head is differing. So for hospital, it is 230 liter. One day 230 liter is being used. Flushing purpose 110 is being used. So in cinema theaters and concert halls and theaters, it is only 5 per seat. It is used with seat only. How many seats are there? With respect to that, only for domestic purpose, they are using only 5 liters. Because in cinema theaters, you know that we are not using much uh, water. Okay, we don't want like we might be using only for flushing or toilet or something like that. So here it is 5, flushing it is 10 per seat. So 100 seats are there. 500 will be for domestic as well as 1000 will be for the flushing purpose. Okay. So depending upon different type of building, go to this and see how much liters is being used per day by one people or per seat. Okay, for domestic purpose and for flushing purpose also. Okay. By this way, we will be able to know the quantity, the quantity. Okay, how much liter that we need or the demand, we can just take it. So it can be 1 day or 2 day storage, or it can be half day storage also. It depends upon our application and need. Correct. So this is known as water balancing. Water balancing. Okay. This is the way that we will be able to know. So all these things we have to decide. In the initial class itself, we have tried to design, or we have found out the overhead tank capacity. We have found the underground tank capacity. Correct. Okay. And all those things we have already found out. Okay. So this is called as water balancing diagram, so that according to our demand, we can supply from the source. Okay. If there is something extra, we can just, or if there is some surplus water, that surplus water can be or should be discharged to the municipal sewer. Okay. It will be flowing to the municipal sewer. Okay. So this is called as water balancing. So when you are trying to do a project, you have to balance the water distribution, okay, in such a way that you should not waste any water, or some water, if it is wasting in a sense, some surplus water is there, that water has to be discharged, okay, into the municipal. So it's water balance. Now coming to the STP. STP means sewage treatment plant. There are different sewage treatment plant available, okay, in the market. Okay, there are different sewage treatment plant. So as we are ABP consultants, we do projects, and what we do is that we can calculate the capacity of the sewage treatment plant. Okay, the same method we can use it. Okay, the same method means for different, depending upon the category of the building, we decide how much liters of water is being used by a person. In cinema theaters or in auditoriums like that, we will be calculating depending upon the number of seats. How many seats are there? And by the table, we will be selecting the liters. Just we have seen right now, like for NBC. And from there, we will be calculating for if there is 500 seats. Okay, 10 liters per is being used. Okay, for example, so 5,000 will be the tank capacity, or 5,000 will be the STP or demand per day. Okay, so we will be or 5 KLD will be calling it as 5 kiloliter per day. Okay, so when you try to contact a STP designer or STP supplier, you will ask us how much is the capacity that you need, 5 KLD or 10 KLD or 40 KLD or 50 KLD. They'll be noting it in KLD only, kiloliter per day. Kiloliter per day. Okay. So yeah, so depending upon the water that is required, we can calculate the amount of water. Okay. So here, how much water that we are utilizing. So here you can see. So for STP, we will be using both the flush water as well as normal domestic water also will be sent to the STP only. Instead of STP, if you are using this septic tank, okay, septic tank, we will be sending only the waste water from the water process. Soil waste only will be going into it. We will be calling it as soil waste, where uh, 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 where the wastewater will be collected in the wastewater tank, and the soil waste or the waste or the solid waste that is coming out from the water process with the water is being sent to the septic tank. So in the case of plant, both the waters also will be sent to the same treatment plant only. Okay? So depending upon the applications, on depending upon the locality in the sense the space requirements, in our market there are different types of uh, STP available depending upon the process of treatment. It can be aerobic, it can be anaerobic, it can be used. Different methods are there. Okay, there are different methods of purification of water. Depending upon the cost and effectiveness, you can choose whatever that you want. So some of the sewage treatment plant, maybe will be using this MBBR, which means moving bed bioreactor processes. That type of STP is there. Okay, NBR technology is there. Membrane bioreactor technology is there. SBR is there. Sequential batch reactor is there. What is the difference between this is that the mechanism of purification will be a bit different. Okay. Okay. Then biofilters are there, bio toilets are there. Okay, here on the bio toilets are there. Okay. Then submerged aerobic fixed filling processes is there. Activated sludge process is there. Okay, there are different types or different types of sewage treatment plants are there. Okay. So here when we get a project, what we do is that from our side we can just calculate the capacity. Okay. Or if we have a project, we can just contact the suppliers or the contractors, mainly the suppliers and contractors, and we will be saying to them that this is our requirement, this is our project, this is our location, this is our application. Like if it is for auditorium, auditorium. If it's for residence, residence. Residence in the sense like STP will be used for this residence, like villas or something like that. Okay, for a large area, only we will be using STPs. So in that case, we will be calling the STP distributors and the suppliers. They will be coming and they can install and all those things. They will be giving all the design. They will be giving the rate. They will be giving all those equipment and everything will be given. Okay? As a quotation, they will be given. And I will show you one quotation. In that everything will be written what is the process that is carried out, and they will be saying that we can use this type of STP there, or we can use this type of STP there, depending upon the requirements. Okay, some in some cases you can use aerobic type. Some cases we cannot use anaerobic, because for example in auditoriums and all, people won't be coming daily. Some events will be occurring, and that events only there will be people will be coming. So daily there won't be processes. So in such cases, the way or the selection of the uh, so depending upon the location and depending upon the application, uh, and depending upon the cost, okay, depending upon the effectiveness and depending upon how speed you can get the treated water, probably that how purified that treatment water will be, treated water will be. Depending upon that, you will be having different types of uh, uh, STPs. Okay. So when we get a project, we'll be calling them, and if you are saying that okay, this much 500 seats are there or 1,000 seats are there, they itself they will be calculating and they will be saying that okay, this much is the capacity of the STP that you need kiloliter per day, and these are the different chambers, and this is the technology that we can use it here, and this much pump should be there. Or, this much tank, this much dimension tank has to be placed. all those things, and the details will be given by them. Okay, so so I will show you a quotation where I was having a project. Okay, I was having an auditorium project in Trivandrum, okay, in Kerala. So I have asked them and I have called them, and they have given it. Okay, so initially they will be given like this only from their company. Okay, the Green Solutions India. Okay, and our address and my name only this. Okay, all those things they will be given, and the initial note will be given. This is just for your idea, okay? Just to understand how a quotation will be there, okay? And I got almost 40 kiloliter per day. 40 kiloliter per day. Actually, when we calculate that 40 kiloliter per day is not, you know, it's a little bit more, but they have just given this, okay? So they have all given this their brief description about the company. Then what they have given is that the technical note of the effluent to be generated 40,000 liter per day. So the number of people per day to attend 1 day function. So I have given my project details to them, as well as I have given my design to them. Design in the sense the auditorium design and the plumbing design I have given to them. They shared, and they have calculated the number of seats. With respect to that number of seats, uh, they have taken 40 liters of water is being used per person. Okay, okay, and they have multiplied and they got 26,000 liters. So 26,000 liters is the water demand. Okay, water or that is a capacity. But not only in auditoriums, there was some cooking for, and some kitchen was there. So, from kitchen also, water will be generated. For washing also, water will be generated. Okay, and they have assumed as 14,000 liters is being used for cooking and washing. Okay, and they have just added this 26 plus 14, and they have came to an idea about 40,000 liters. Okay, actually, this 40,000 liters is much enough. Okay, it's much more than enough, because when we try to look for water storage capacity, as this 40 liters is huge. It seems this 40 liters is huge. So we don't want really 40 liters and all. Okay, I think almost 20 liters is enough for an auditorium. So they have just taken a safety factor and they have multiplied and they have given this. Okay. Afterwards, I called them back and they have reduced the capacity of the uh, sewage treatment plant (STP). So this is the way that they will be giving quotation, and they will be giving the capacity. 40,000 liters is the capacity of the STP, and they will be giving us the notes the what to be we should not give grease or any kitchen waste directly into it. Some notes will be given. Okay, please let us know clearly about the invert level before execution, because invert level and all those things we have to do. Invert level, what is the slope of the pipe. So that slope only they will be able to design this or construct any tank, right? So there should be no okay? And, all these things, extra details we have to uh, send them. Like, please let us know clearly about the invert level before execution. If the invert level goes more than 3 feet, it is better to provide a collection tank and 2 pumps extra. So these are their requirements. Okay, so we will be giving invert level goes beyond 3 feet, so that the tank should come below that, right? So if you are trying to build a tank below a certain level, okay, it will affect all other tanks, because sometimes this tank will be moving in gravity only. Okay, sometimes pump should be given. Okay, so that's why only they have said that, like, otherwise pump has to be given. Extra 2 pumps has to be given. Okay. Then the whole plant is designed in such a way that the water overflows from one process to other process by gravity. Okay, so we require proper disposal options for treated water other than gardening and groundwater. So they will be giving some suggestions about this. Okay, so it has been flowing by gravity only. So slope should be given. Okay, all those things. And some waste food and draining of oils from the kitchen should be avoided. So, sometimes some aerobic bacteria are there inside, uh, you know, inside the STP for treatment processes. So when this food waste and like the oils will come, it will affect its uh, you know it will affect its process. It will affect its process. So we should avoid this oils and all those things. So we can keep grease receptors, okay, or grease or oil separators. We can use it, okay, before coming into the uh, STP. Okay, so disposal of non-biodegradable items in bathrooms and toilets should be controlled. Okay, 24 hours backup three-phase is required to operate the plant smoothly. So these are some notes that they will be giving us to understand. Okay, so, these are some of the things that we need to know. Now, that they will be giving. Okay? Now, activated sludge processes. These are their features and how what are the salient features, okay, of their STP. Okay, will eliminate the smell and everything amount of sludge only will be the less space requirement, loss operating cost. This is, when they give a project, okay, or when they give a quotation, they will be specifying about their specialities of their you know their STP. What is the difference with STP? So, what as an MEP consultants that when we design a project, okay, if we need an STP, we will be sending the details not only to one STP uh, supplier or contractor. We will be giving to at least 4 or 5 people, okay, and we will be giving the information, okay, how much people are there, what is the application, what is the place, all those things will be given, and we'll be asking them to give a proper quotation, okay, with the cost, and in that they will be giving information about their special features, their advantages, their small disadvantages if any, and whatever type of equipments they are used. Okay, all those things will be shown in the quotation, and they will be showing the cost also. They will be showing the advantages also. At last, what we will be doing is that we will be comparing all those 5 different quotations. We'll be looking and we'll be studying, and we'll be discussing with the client, and the client will be selecting any one of the plan depending upon the cost, effectiveness, and all those things. Running cost, operation cost, electricity cost, everything like that. Okay. So these are some of the features that they are given. Okay. So then so they have used SBR type. They have used SBR type of it. Treatment cost solely, and different stages are there. Okay. Filling stages there, reaction stages there, settling stages there, decanting stages there, idling stages there. Okay. These are the different then sludge wasting is there. Then finally we'll be getting the treated water. Okay. So when you're seeing a flow chart, okay, for designing, they will be giving the flow chart also. They will be giving the flow chart also. There will be initially there will be a sewage inlet. Then there will be a bar screen chamber for the bar screen will be there. All other solid or large waste will be collected there. Then after that, then water will be disposed into the anaerobic digester. Okay, from there it goes to the utilization come collection chamber. Okay, and this will be from the if you are using a kitchen and all, the kitchen's waste will be coming here, and goes to the oil and grease trap. From there you will be getting water which is not mixed with oil, then that also will be going to the utilization tank. From there it goes to the SBR tank and the sludge digester. Okay, sludge will be there, that will be going to the sludge digester. After SBR tank it will be going for filtration, then for safe disposal. Okay, and you can see these 2 arrows here. This arrow shows it is by gravity only. All these things it will be flowing from sewage inlet to the bar chamber. It is flowing by the help of gravity only, from there to anaerobic digest also through gravity only. Sludge, these all things will be flowed through gravity only. So we have to give a proper slope and all those things here. This is not our work, but they will be doing all these things. And you can see this thing, utilization pump, collection tank. This is by the help of pump only. From here to SBR tank to the sludge digester and to the filtration system. It is by pump. From filtration to the safe disposal, it is by again by gravity. So these are the different things. Okay, different processes which is there in the sewage treatment plant. Okay, and then they will be giving the estimate how much amount. Okay, all these things they will be showing us. Okay, so civil work there they won't be doing it. Okay, the civil work will be done separately by another people. Okay, this amount is only for their equipment and their pump and motor and all those things. Okay, so a civil engineering estimate alteration, we can use existing tanks with some alteration. Or if you have some tanks there, they can use that tank. Okay, if there is no tank, means they have to build a new tank. So if there is some tanks already in that location for some other purpose or for this purpose itself, like septic tank or something like that, they can make some alteration and they can, because for this STP we need some different tanks are there, holding tanks are there, filtering tanks are there, okay, and treatment water tanks are there. If you can make some alteration in it, you can use that. Okay, then electromechanical and biological engineering. Okay, their amount is 7,50,000 for 40 KLD, kiloliter per day, or 40,000 liters. It cost almost 7,50,000 only for their equipment only. Okay, then they will be giving what will be the operational cost. Okay, and the 7,50,000 will be the cost for 40,000 plus extra GST should be given. Then a note on operational cost and economics. So they are giving a note on the cost of operation. Okay, for 14 liter cube per day plant, expenses to be incurred on a month-on-month basis. So each month they have to have an expense like this. Okay, electricity bill 47 units per day. So for 40 kiloliter per day, we need an electricity of 47 units per day. So it costs almost 14,323. This is depending upon month-to-month basis. Okay, in 1 month only. Other expenses 3,000. So total 17,323 rupees will be needed for an operational cost for each month. So operation cost for treating the wastewater meter cube per day. Okay, cost for the month is 18,000. The operation cost. Okay. The above mentioned civil estimate is approximate. We will provide only civil structure drawings and the client has to execute the same. Okay, so they can provide the civil structure drawings. The STP contractors and all those people can provide the civil structures, but the client has to execute that. They won't execute or they won't build anything. They will give you the diagram and they will give you the dimensions and all those things. Okay, depending upon their system. And this 7,50,000 won't come in civil works. Okay, excluding civil works only they have said 7 lakh. So civil works is extra. So the list of materials they have used for their sewage treatment plant is, these are the numbers. Supply and installation for return sludge pumps. Sludge pump is there that we are using by not by the gravity, by pump only. 0.6 HP at 3 pH point submersible only. So 1 number. Supply and installation of sewage transfer pumps 2 number. Installation of decant pump filter feed pumps 2 number. Motor for air blower because we are using aerobic, so 2 numbers. Supply installation air compressor 2 numbers. Dual media filter. So these are the filters and pumps that they are using for their setup, SBR technology. These 2 numbers. Supply chlorine dosage pump for filtration. Chlorine dosage pump is there 1 number. Bar screens. Okay. 1 number. Electrical panel board 1 number. Okay. Plant piping 1 lot. Okay. Supply and installation of hose and pipe board diffusers with accessories 1 lot. Tools, kit, safety gloves, fire extinguishers, scoring 1 set, etc. Okay. So what are the equipments and what are the things that comes in their STP? All those lists will be given to them. Okay, and section 3 about the electrical and instrumentation notes. Okay, the entire electrical system is mounted on a single panel, and all those details will be given, digital and on-off lighting indications, and kit relays about the electrical and instrumentation works will be also shown there. So A to Z they will be showing to us. Okay, and the approval of the pollution control also. Okay, we cannot just directly give a 40,000 liter or something like that. We need to get approval from the pollution department also. Okay. So the quotation for a 40 meter cube per day capacity wastewater treatment plant, the total project estimate indicates the price of the designing, detailed engineering, supply equipment, erection, commissioning, consumer for stabilization, test run, and provision of operation and maintenance manual. So supply of water pollution control equipments, design and detailed engineering. So this is the subdivided. Okay, they have subdivided how they got this 7,50,000. They have given design and detailed engineering 25,000, mechanical equipment, control valves, fittings, etc. 4,90,000. Microbial aggregator for stabilization 15,000, electrical and instrumentation 1,95,000, erection, commissioning and supervisory charges 25,000. So when you add all these only, you will be getting 7,50,000. Okay, and GST is extra. 18% has to be extra also. Not only that, civil works also will be extra. Okay, and their payment terms 60% initial, all those things will be given. Tax and duties, validity. Okay, 45 days from the date of proposal. Okay, and these are the different things. Okay, they will be shown. Line scope. Okay, civil work, waterproofing. Okay, cleaning of all tanks. All those line scope also will be mentioned. Okay, so when we ask for a quotation, they have to give all these informations to us. Okay, and we have just seen about SBR only. SBR means sequential batch reactor only. That is one type of STP only. There are NDBR technology, NBR technology is there. Okay, different technologies are there. Okay, so sewage treatment plant normally we can find out the capacity and not only that, they will be giving the if the client approves, they will be giving the drawings also. Okay, they will be giving the drawings also. Okay, they will be giving the plan as well as the section drawings also. They will be giving to us. Okay, depending upon their capacity and their design, they will be giving the dimensions, length, width, height, different chambers, all those things they will be giving to us. Okay, so for example, like show you. For example, how they will be giving is, so this is one of our other project only. Actually, I need a 5 KLD. Okay, 30 to 50%, 5 KLD, which means 5,000 to 7.5 kiloliter per day. They have a range. Okay, so they will be saying only 5 to 7.5, like that only they will be saying. Okay, so this is the top view. This is the plan view. This is the plan view. Okay, this is the top view and this is the plan view. They will be giving all the details and designs and drawings about the STP. Okay, they will be giving all the details about the STP. Okay, depending upon their type of technology that they are. So here there will be a primary tank, liquid depth is there, volume 6 kiloliter, and a buffer tank is being given, which quantity is given, manholes are given, pipe is given. Okay, vent pipe is given. This is the top view. Okay, and manhole 2, manhole 3. Okay, and what cutout is there. Okay, and goes to the SBR. This is also SBR tank only. Volume is given, and then finally it goes with treatment water tank. Okay, treatment water tank. So this is the plan view, and dimensions is given 1.8 into this is 1.1. All these are in mm. Then 3.1 meter, 2.2 meter, 900. Okay, from this pipe, these are pipes only. Okay, different dimensions are given. These dimensions will be provided by the respective suppliers. Okay, and they will be coming there and they will be installing it. Okay, civil works has to be done by the client. Okay, drawings, rest, everything will be given by them itself. Depending upon all those things, they will be given to us, and I have already shown a quotation. And if it's a section view also, they will be showing us. Okay, they will be giving the section view also. So this is the section view. This is the inlet pipe. Okay, this is the ground floor, ground level, and water level is being shown here. Okay, different pipes are there. This is the primary tank. Then the buffer tank will be there. Then the SBR tank will be there. Then finally it goes to the treatment water tank. Okay. So all these invert levels, cutouts, pipe diameters, okay, how they are trying to set up all those things they will be used. Okay, and this inlet pipe, okay, waste water transfer, okay, sludge recirculation pump, all those things are given here. Okay, and manhole, MH1 manhole only, its dimensions and all those things are given here. Okay, so this is 5 to 7.5 kilometer per day capacity channel. So this is the way that we will be studying about the sewage treatment plant. Okay, so different types of sewage treatment plants are there. Okay. For example, like if you want to show you different types of sewage treatment plants are there. Upflow anaerobic sludge blanket reactor. Okay, activated sludge process. Then submerged aerobic fixed filling process. So most commonly used one is this. Nowadays, the most commonly used that I have seen is this MBBR, moving that bioreactor process. This MBR is used. Okay, membrane bioreactor. This SBR is used. So these three are the mainly used one that I have seen. Okay. Then the rotating biological contactor, biotoilets, biofilters. Okay, these are the different things. And not only that, more sewage treatment plant is also there by using these different electrodes. Okay, positive anode, cathode, that electrode also. By the help of that electrodes also, we will be using STPs. Okay. So depending upon the usage and depending upon the space requirement, okay, different types of sewage treatment plant. So sewage treatment plant will be mandatory in some cases, like a huge building and all those things. We want to be able to use this safety tank. Safety tank will be very huge if you are trying to do it. So in that cases, to get approval, we have to sewage treatment plant. Go for sewage treatment plant. We can calculate its capacity and what is the benefit of the sewage treatment plant is that we can just treat it and we can we getting good water out of it. Okay, good water that we won't be able to drink it. Okay, that we maybe we can use it for gardening purpose and flushing purpose. Okay, from the water that is coming out from the sewage treatment plant. And problem is that we need maintenance. Operation cost also is a concern. The operation cost month to month, operation cost is there. So you have already seen for a 40 KLD. Okay, it costs almost 20,000. Okay, almost 20,000 rupees is being spent for that operational cost and all. Because the electricity, 47 units is being, consumed. Okay, so depending upon all those things, that also is a concern. So we have studied today about the water balancing. Okay, so water balancing we have studied. So we have studied about the STP and the sewage treatment plant. So normally when it comes to plumbing, we use sewage treatment plant. We use a tank. Okay, etc. Okay, sewage treatment plant is very better only. Okay, and there are many benefits of it. Okay. Uh, and, when it comes to a larger buildings and all, we have to use sewage treatment plant. We have to use sewage treatment plant. Okay, instead of septic tanks. Okay. We have already seen that the civil cost and all those things should be bared by the people only. Sewage treatment plant persons, they will be focused only on their technology and their, they will be giving the diagram and design and all those things. Rest everything and the equipments and all those installation will be done by them. Electrical also will be done by them. Civil and all those things will be taken care. That is extra. But what under that we need to extra that they will be saying to us. Okay, they will be saying to us. For example, they have already mentioned that what is the client scope. Okay, what is the client scope? They have already written here. At the end, they will be written writing there. So you can see here. Client scope. Civil works for mass screen chambers, utilization tank, aeration tank, all those things is to be done. Okay, waterproofing of all tanks and provisions of all tanks after finishing the civil works. Connection of fire receiver line from the building to the STP. Okay, incoming cable. Okay, specified size from the nearest panel. So these things won't be done by the STP persons. Okay, maintenance of STP with our own manpower from the date of commissioning. Okay? So that's one of the things that if they come and set up an STP, the maintenance of STP with their own manpower, because they have produced their technology and they have implemented that. So then getting STP related government approvals, so they won't be doing all those things. So these things they have to bear, or the client has to do it extra. Okay, issuing the e-student form for the time of utility supply. Okay, because this for approval and all those things they need different forms. Disposal of treated water from STP to end point. Okay, after the treated water, what they have to do, all those comes for the client role. Okay, all those things is uh, not involved. Okay, for the person who is trying to install the STP. Okay, so provision of extra pump required for capacity of reusing of treat water. So if you are using for gardening, we need pump, right? So that pump won't come in sewage treatment plant, uh, scope. Okay. So they'll be normally they'll be mentioning it. They'll be normally mentioning it. Okay. Uh, so yeah. So today we have just focused on sewage treatment plant and water balance. Okay. So just we need to have some idea about this thing only. Depending upon different types of STP, the chambers will be different. The processes of cleaning or treating the water will be different. Okay. So today we can just wind up our class for the time being. Tomorrow we'll be dealing with other topics. So is there any special doubt or any specific doubt related to these topics? Is there any doubt? Yeah, so today we have just studied about the basics of this STP only. There are much more to study about STP and all, designing and all those things. Training in the sense, what are the different treatments? Okay, that are our normal things only. Yeah, so I think there is no much doubt in this STP. Okay, so we can wind up our class. So see you tomorrow. Okay, fine. And the link will be sent to you and just go through it once more regarding the STP and water balance. study it. Okay, and the different informations about the STP, different types of STPs are available in the site. Different sites are there. Just go through. You can go to YouTube also for the, how it is being processed. Okay, different animated videos are also available. So if you want to know more about this STP and how it is being used, you can just look onto it. Okay. So thank you so much. Thank you.